Welcome, dear listeners, to another episode of Cosmic Queries, the podcast where we unravel the mysteries of the universe, one story at a time. I'm your host, Noah, and with me is the ever-curious Olivia.
Hi everyone, I'm excited to dive into today's topic with all of you.
And what a topic it is! Today, we're tackling the legendary three-body problem. It's a puzzle that has stumped the greatest minds for centuries, and it's not about a crime scene with three victims, as the name might suggest. No, it's about predicting the motion of three celestial bodies under the influence of nothing but their own gravitational pull.
That sounds complex. I can't wait to hear more about it.
Oh, it is. And it's not just a theoretical exercise. Understanding this problem has implications for everything from space travel to predicting the Earth's future climate. So, buckle up as we embark on a journey through time, space, and gravity. Imagine you're at a dance, but instead of people, the dancers are planets and stars, each moving to the rhythm of gravity. This is the cosmic dance of the three-body problem. Now, let's start with the basics. In physics, we can predict the motion of two bodies, like the Earth and the Moon, quite accurately. But introduce a third body, say an asteroid, and things get unpredictable.
Unpredictable? How so?
Well, when three celestial bodies interact, their gravitational forces create a complex system where predicting their movements becomes a challenge. It's like trying to predict the outcome of a game of billiards after the break shot.
So, there's no way to know where they'll end up.
Not exactly. We can make approximations, but the three-body problem defies a simple, one-size-fits-all solution. Each scenario is unique, and small changes in the beginning can lead to vastly different outcomes. This sensitivity to initial conditions is a hallmark of what we call chaotic systems.
Chaos in space? That's both fascinating and a little scary.
Indeed, it is. But fear not, for this chaos has a method to its madness. Over the next hour, we'll explore historical attempts to solve this problem, its implications for our understanding of the cosmos, and how it even connects to time travel and science fiction. Throughout history, the three-body problem has been like a siren call to mathematicians and astronomers alike. The first to take up the challenge was none other than Sir Isaac Newton. With his law of universal gravitation, he could solve the two-body problem, but the third body left even him scratching his head.
Newton couldn't solve it. That's surprising.
It is, isn't it? But that's the beauty of science. Even the brightest minds encounter puzzles that push the boundaries of our understanding. Fast forward to the 18th century, and the problem caught the attention of the French mathematician Pierre-Simon Laplace, who introduced perturbation theory to tackle it.
Perturbation theory? That sounds complicated.
It can be, but here's the gist. It's a method to find an approximate solution by starting with a simple problem and then adding in small perturbations or changes. Laplace's work laid the groundwork for what would become celestial mechanics.
So, did he solve the problem?
Not quite. His methods worked well for small perturbations, but the three-body problem often involves interactions that are anything but small. The quest continued, and in the 19th century, the problem was formalized as part of the famous list of unsolved mathematical problems, known as the Hilbert problems.
Wait, so it's still unsolved?
In a way, yes. But every attempt has brought us closer to understanding the intricate dance of the cosmos. And who knows? Maybe one of our listeners will be the one to crack it. As we continue our cosmic voyage, let's leap into the modern era. The three-body problem isn't just a historical curiosity. It's a cornerstone of chaos theory. This is the study of systems so sensitive to their starting conditions that predicting their future behavior seems nearly impossible.
Chaos theory? Like the butterfly effect?
Precisely. The butterfly effect is a concept within chaos theory where a small change in one state can result in large differences in a later state. It's often said that a butterfly flapping its wings in Brazil could set off a tornado in Texas.
That's an incredible thought. How does this relate to the three-body problem?
Well, in the context of the three-body problem, imagine if the gravitational pull of a small asteroid passing through our solar system could influence the orbits of Earth and the Moon. The effects might be tiny at first, but over time, they could lead to significant changes.
So, the stakes are high when it comes to understanding this problem.
Absolutely. And it's not just about celestial mechanics. The principles of chaos theory apply to many other fields like economics, biology, and even weather forecasting. By studying the three-body problem, we gain insights into the unpredictable nature of complex systems all around us.
I guess that makes the universe the ultimate unpredictable system.
It does, and that's what makes studying it so thrilling. Up next, we'll look at how scientists today are using supercomputers to simulate the three-body problem and what they're discovering. In our quest to comprehend the three-body problem, we've enlisted the help of some powerful allies, supercomputers. These computational behemoths can crunch numbers at an astonishing rate, allowing us to simulate the gravitational dance of three bodies in space.
How do these simulations help?
They allow us to explore countless scenarios and observe the outcomes. Think of it like running through millions of what-if situations to see how slight changes can lead to dramatically different futures.
That sounds like a game changer for astronomy. It is. With supercomputers, we can test our theories and refine our models. We can't solve the three-body problem analytically, but we can get a glimpse into the range of possibilities it presents. So, we're using technology to tackle a problem that's been around since the dawn of science.
Exactly. And it's not just about observing. We're also learning to predict. By identifying patterns within the chaos, we can make educated guesses about the future positions of celestial bodies.
I guess you could say we're learning the steps to this cosmic dance.
Beautifully put. And as we learn, we inch closer to answering some of the biggest questions about our universe. In our next segment, we'll dive into the world of science fiction, where the three-body problem inspires tales of interstellar intrigue and time travel. Now, let's take a turn into the realm of imagination. The three-body problem isn't just fodder for scientists. It's also inspired a whole genre of science fiction. From classic tales of space exploration to modern epics that span galaxies, this problem has been a muse for storytellers.
Are there any famous works we might know?
Absolutely. One of the most renowned is Liu Cixin's The Three-Body Problem, the first book of a trilogy that explores an alien civilization's struggle with this very issue. It's a masterpiece that blends hard science with a gripping narrative.
Sounds like a must-read for our listeners.
It's a must-read for anyone who loves a good space opera. But the influence doesn't stop there. The concept of three bodies in a gravitational dance has been used to explore themes of fate, free will, and the nature of the universe itself.
It's amazing how a scientific problem can lead to such profound storytelling.
It is, and it's a testament to the power of human creativity. When faced with the unknown, we don't just seek answers. We create worlds. In our next segment, we'll look at how the three-body problem has influenced other areas of culture and thought. The three-body problem resonates beyond the pages of science fiction. It echoes through various facets of culture, challenging our perceptions of reality and our place in the universe.
How so?
Consider art. Artists have long been inspired by the celestial dance of planets and stars. From Van Gogh's Starry Night to modern digital art, the cosmic ballet has been a muse for visual creativity.
I've always found space to be a captivating subject in art.
And it's not just visual arts. Musicians have composed symphonies that mirror the orbits of celestial bodies, and poets have penned verses about the lonely asteroid wandering through space, influenced by unseen forces.
It seems like the three-body problem has a way of sparking the imagination across all mediums.
Exactly. It's a concept that transcends science, becoming a metaphor for the complex interplay of forces in our own lives. Relationships, economics, even politics, they all can be viewed through the lens of this cosmic conundrum.
That's a profound way to look at it.
It is. And as we delve deeper into the implications of the three-body problem, we find that it's not just about understanding the universe, it's about understanding ourselves. As we've seen, the three-body problem isn't just a theoretical puzzle. It has real-world applications, especially in space exploration. Understanding the gravitational interplay between celestial bodies is crucial for navigating the cosmos.
How does this affect space missions?
Well, space agencies like NASA use the principles derived from the three-body problem to plot trajectories for spacecraft. These calculations help in designing slingshot maneuvers, where a spacecraft uses a planet's gravity to gain speed and change direction.
That's like getting a free ride through space.
Exactly. It's an energy-efficient way to travel vast distances. The famous Voyager probes used this technique to visit the outer planets and are now on their way out of the solar system.
So, The three-body problem helps us reach the stars.
It does, and it's also vital for understanding the stability of multi-body systems, like satellite constellations. With the rise of mega-constellations for global internet coverage, ensuring that satellites don't collide is more important than ever.
I never realized how much space travel relies on solving complex problems like this.
It's a testament to human ingenuity. We're using mathematics to conquer the final frontier. In our next segment, we'll explore potential future breakthroughs that could come from solving the three-body problem. The three-body problem isn't just a relic of the past or a tool for the present. It's a key that could unlock the future. Solving this problem could lead to breakthroughs in various fields, from astrophysics to technology.
What kind of breakthroughs are we talking about?
For starters, a better understanding of the three-body problem could revolutionize space travel. Imagine being able to accurately predict the gravitational interactions in multi-star systems. This knowledge could be crucial for future interstellar missions.
So, we could be looking at a new era of space exploration?
Precisely, and it's not just about exploring the stars. Solutions to the three-body problem could improve our satellite navigation systems, making GPS even more precise. It could also lead to advancements in understanding gravitational waves, those ripples in spacetime that Einstein predicted.
That's mind-blowing. The implications are huge.
They are, Olivia. And there's more. On Earth, these advancements could impact climate modeling, helping us predict weather patterns and natural disasters with greater accuracy. It's a perfect example of how studying the heavens can benefit life here on the ground.
It seems like the three-body problem touches everything.
It does. And as we continue to peel back the layers of this cosmic onion, who knows what secrets we'll uncover? In our next segment, we'll discuss how the three-body problem is not just a challenge to be solved but a source of inspiration for generations of dreamers and doers. As we near the end of our journey today, let's take a moment to appreciate the three-body problem not just as a scientific challenge, but as a source of inspiration. It's a reminder of the boundless curiosity that drives us to explore the unknown.
It's incredible how a problem can inspire so much wonder.
Indeed, the three-body problem has sparked the imaginations of countless individuals. It's a celestial muse challenging us to think bigger, to reach further, and to dream of what lies beyond the horizon.
And it's not just for scientists, right?
Absolutely not. It's for anyone who looks up at the night sky and feels a sense of awe. It's for the dreamers, the artists, the writers, and the thinkers. It's for all of us who are on this pale blue dot, spinning in a dance with the cosmos.
I think that's a beautiful sentiment.
It's a sentiment that unites us. In the grand scheme of the universe, we're all part of this intricate dance. The three-body problem reminds us that there's so much more to learn, and it's the pursuit of that knowledge that makes life so enriching.
So, what's the takeaway for our listeners?
The takeaway is that the universe is full of mysteries waiting to be solved. And each one, like the three-body problem, is an invitation to adventure. It's a call to never stop asking questions, never stop learning, and never stop reaching for the stars. As our time together comes to a close, we reflect on the journey we've taken through the enigmatic three-body problem. It's a journey that has taken us from the depths of history to the frontiers of the future.
It's been an incredible ride. I feel like I've learned so much.
And that's the beauty of it, Olivia. The three-body problem is more than just a puzzle to be solved. It's a gateway to discovery. It teaches us humility in the face of the vast unknown and inspires us to keep pushing the limits of our knowledge.
So, what's the final message for our listeners?
The final message is one of hope and perseverance. The universe is vast and full of wonders, and though we may not solve every mystery, each step we take is a victory in its own right. The three-body problem reminds us to embrace the journey, to cherish the questions, and to always look up with a sense of wonder.
And to never be afraid of not knowing, because in not knowing, we find our greatest potential.
Exactly. To our dear listeners, thank you for joining us on this cosmic quest. We hope you've enjoyed it as much as we have. Until next time, keep your eyes on the stars and your heart full of curiosity.
Goodbye, everyone, and keep dreaming.